Okay, I'm going to make a short video here just on periodic trends, and I'm still going to leave two of those out until my next video. And so I'm going to leave out ionization and size because that relates to some other stuff, so I don't want to get you confused. When you look at a periodic table, you can look at a whole bunch of different things, and there are trends that you can see within the elements. Everything that I have here in blue, so in this area here, those are metals, which means that a vast majority of the elements are metals. Now, it's not abundance, it doesn't tell you how much of it there is, but most of the identities of these elements are metals. These are your metalloids, the ones in green, like this little stair step type of thing right here. Those are really, really important as semiconductors and a whole bunch of other things that come into your daily life. And then in the red, we have the nonmetals. Again, very, very important to you because there's carbon, oxygen, and even hydrogen here, so those are the building blocks of you. You can look at groups, and that means columns, and we usually say this, like this one, we don't look at the columns so much in the middle here, or these guys would be your groups. So groups go up and down, periods go left to right. And sometimes you'll see these labeled as 1A, 2A, 3A, 4A, 5A, 6A, 7 and 8. And sometimes you just see the 1 through 18. Both of those have meaning, which hopefully will become apparent sort of in time. Groups down the periodic table have much more in common as far as the reactivity is concerned, and that leads me to this. And sorry, you can't fit all of this on one page here. So something to note, these two columns kind of fit in right here. So these are the lanthanide and actinide series, and they are periods. That's not that those didn't exist. It's just that if we could fit those on one page, those would be inserted about right there. Okay. This first group is referred to as the alkali metals. Here, the second group is the alkaline earth metals. This stuff that's in the middle, those are the transition elements. Technically, these are as well. And then we have noble gases at the very end, and halogens are right before that. Sometimes you refer to this as chalcogens, but I don't usually refer to that very often. Okay, so here we've got the metallic character. So metals are items that are ductile, can conduct electricity, can be cut and still retain their properties, things like that. The metallic character of elements increases down and to the left, so francium would be sort of your pivotal point for that. And electronegativity is just the opposite. Now, this is a very, very, very important thing when it comes to organic chemistry, and your next class will certainly involve it. And this is just the opposite. So we increase as we go up and over, meaning, or better yet, the closer you get to fluorine, the more electronegative something is. And an electronegativity has to do with how well electrons share between each other. Things that are highly electronegative means that you're basically going to have one of the two atoms in a pair hog the electron, so they sort of pull it towards itself, and that's how that works. Okay, on to the next one.